Today we will look into standards and tolerances. What are these standards and codes? When we design any product, system, or any machine element, it must follow certain standard for it to be safe, reliable, and be able to sell in the market. So, what is the standard? It is simply a set of specifications for parts, materials, or processes meant to achieve a certain level of uniformity, efficiency, and quality. For example, let's assume that a functionality has to be achieved through some machine element. Fastening, let us say fastener. If you are asked to design a fastener, each one of you might come out with your own design. So when we come out with a product with several different designs of machine elements, it is really difficult to uh, uh, maintain it because the inventory size increases, inventory of tooling, size, shapes, and varieties will increase, right? So we don't have any uniformity. So if there is a repair, it is very difficult to find the component designed by you, right? On the other hand, code specifies how an analysis or design or manufacture of certain thing should be done. The idea is to ensure certain level of safety, efficiency, and then quality. So safety codes basically do not imply any absolute safety, as it is difficult to provide absolute safety. So we as operators must be cautious enough to use a product or a system as specified in the user manual. The standards and codes are developed by the professional bodies in each of the discipline. So there are several standards in every discipline. So some of the standards which are of interest to mechanical engineers are those developed by America, it is United States of America, German, Japan, India, Britain, and so on. So a few of them: Aluminum Association, American Gears Manufacturers Association. We will use this in the gear design, probably in your design of machine elements too. American Institute of Steel Construction, American Iron and Steel Institute. We use AISI designation of steels. We will see in the upcoming session. ANSI, ASM International, American Society of Mechanical Engineers, ASTM, meant for setting the standards for testing. You would have studied ASTM standards in tensile testing and so on. Welding Society, standards for welding procedure, then Bearing Manufacturers Association, BSI, Fasteners, right? Institution of Mechanical Engineers, and so on. So these are some of the Society of Automotive Engineers, to name a few, right? So as and when you take up the design of a particular machine element, please please look into the associated standard of the particular locality. Okay. See, standardizations are obligatory norms to which the characteristics of materials, products, or processes should conform. So these characteristics include the materials, dimensions, shape of the component, type of testing, method of marking, packing, and so on. So some of the standards which are used in mechanical engineering design are as follows. So standards for materials, chemical compositions, mechanical properties, and heat treatment. So we will look into only Indian standards. Okay. See, the Indian standard for material specification is IS 210. So as an example, we shall see how a grey cast iron is specified. FG 150, FG 200, and so on. FG means grey cast iron. What does these numbers indicate? These numbers are basically ultimate tensile strength in MPa. Similarly, we have a standard for chemical composition, IS 1570 part 4. So how to specify the chemical composition? Here we have an alloy steel designated as 55 CR3. It is read like this. So the carbon content varies from 0.5 to 0.6%, silicon percent from 0.1 to 0.35%, manganese from 0.6 to 0.8, and chromium 0.6 to 0.8%. We will see in the upcoming sessions as how to read this. There is a way to read it. I will explain it. Okay. The next standard is standards for shapes, dimensions of commonly used machine elements. So some of the commonly used machine elements are bolts, screws, nuts, rivets like fasteners, power transmission elements like belt drives, chain drives, and bearings, ropes, keys, and splines. These are couplings. Okay. So IS 2494, Indian Standard 2494, specifies the dimensions and shapes of cross sections of power transmission elements like V belts. So similarly, the dimensions of trapezoidal cross-section belt is also specified, like its width, height, included angle, everything will be specified. Dimensions of rotary shaft oil seal units, they are given in different parts of Indian standards, like its inner and outer diameters, width of the oil seal, and so on. Coming to the next, standards for fits, tolerances, and surface finish of the component. See, for example, IS 2709 will give us idea about what kind of fits have to be selected for a given application to ensure uniformity, safety, and then certain level of quality. The tolerances, like the upper and lower limits for various sizes of the holes and shafts, are specified in IS 919 under the heading Recommendations for Limits and Fits for Engineering. Similarly, IS 10719 will tell us how to indicate a surface texture on technical drawings. So you can also refer to IS 8000 for geometrical tolerancing on technical drawings. The next standard is standard for testing of products. So these actually give the procedures. There is a way the test has to be carried out for a given product like pressure vessel, boiler, any product it could be, to ensure safety and reliability. For example, IS 807 will give us how to design, manufacture, and erect, right, and test a crane and hoist. Okay. Similarly, IS 2825 will give the method of testing of pressure vessels. The last one is standards for engineering drawing of components. So Bureau of Indian Standards on Engineering Drawing Practice for schools and colleges can be referred, right, which will specify how to indicate various components of engineering drawing. So what are the advantages of standardization of various products or machine elements? So the first one is it will reduce the different types and dimensions of identical components, as said earlier, to a small number. As a consequence, it is easy for us to manufacture such standard component on a mass scale in a centralized process. See, for example, here is a bearing company, SKF, which will manufacture bearings, ball and roller bearings required by most of the engineering industries. And when we do such mass production, it will not only reduce the cost, it will also reduce the inventory. The next advantage is that when we have a standard part, it is easy to replace parts which are worn or failed, right? And you can easily interchange it. So as a result of servicing and maintenance will be very, very easy, right? So that is why when we manufacture a product, we ensure that it will adhere to certain standard. The third advantage is that when we apply standard machine elements, it will reduce the time and effort needed to design a new machine. Because see, you don't need to design or manufacture these machine elements every time. You can just pull out it from the manufacturer's catalog and then incorporate in your new product or system. Suppose if you don't have such standard parts, let's assume, the situation would be demanding you to design all of the machine elements right from the scratch, which is really impossible. That is why standardization results in substantial saving of designers' effort and as well as time, money. And when we use standards, it will basically improve their quality and reliability. See, for example, when we go and buy a product in a market, let us say you try to buy a dress or any home appliances, any electronic goods, you will try to buy a branded one which would have followed or implemented standards in their manufacturing. So, and hence the reliability would be increasing. See, when we want to manufacture a certain product or a machine element, if you go to any shop floor, you would have seen the engineer would be looking at the drawing and then he will be manufacturing it. It is in this drawing all the dimensions of the components would be specified. Do you think that it is possible to manufacture the components to the specified dimensions in the drawing? Let us say, for example, if you're asked to manufacture a 35 diameter shaft of length 10 meter, is it possible to manufacture exactly 35 diameter shaft, 10 meter length exactly? It is not possible because of various reasons, like because of inaccuracy of the manufacturing methods or operator error, and there are so many reasons. So in such situations, what we do is we permit a certain level of deviation in the dimension of the machine element without affecting the total functionality of the product. And that permitted deviation from the exact dimension is what we call as tolerance, right? So the deviation can lie between two limits. It will have upper limit or maximum limit and then the minimum limit from the given reference, and that reference is your nominal size or the basic size. This is the theoretical size or the exact size of the element. See, we said like 35 diameter shaft. This 35 is called the basic size or the nominal size. Since we cannot achieve this 35 diameter, so we are permitting some deviation above and as well as bottom, or on only on one side or on the other side. Okay, so it can have 35.02 or 34.98. So if the diameter lies anywhere between these limits, I can achieve the functionality of my product. So this permitted variation, this maximum limit are called the maximum and the minimum limits. So technically we say tolerance as the difference between the two limits, upper and lower limits. So here we have the pictorial representation of the concept of tolerance and the various terms associated with tolerance. So let us take a simple shaft and hole assembly. Okay, so here you have the side view and this side we have the front view. So in the side view you can see, right, the shaft and the hole size shown to their nominal and as well as permitted deviation. This hatched region is actually the tolerance. So the bottom one shaft tolerance and then the upper one the hole tolerance, and on the front side you can see a zero line, that is actually our nominal size. Okay, so you can see to begin with upper deviation of the hole and lower deviation of the hole, similarly for the shaft, right, the basic size of the shaft, right, the tolerance zone for the hole and the shaft. So you must remember this to understand the concept of fits in the next lecture. Okay, you read this, take your time and try to understand. It is very easy to understand. The hatched region indicates the tolerance zone. Tolerance zone means my shaft dimension can lie anywhere between within this tolerance zone. If it does so, I can easily achieve my functionality. There are two types of tolerance specifications. One is unilateral system, where the variation of the nominal size is permitted only in one direction, either on the plus side or on the minus side. See, for example, here the basic size. This is the way we indicate the tolerance. 100 is the basic size or the nominal size, and can you see the lower limit is 0.00 and upper limit is 0.004. Only on the plus side you can have the variation. So what is the lower limit? In this case, lower limit is 100 plus 0.00, that is 100. Upper limit is 100 plus 0.04, that is 100.04 is the upper limit, or this is also unilateral specification of tolerance, where you have the deviation on the negative side. 100 minus 0.004, similarly 100 as the upper limit. Next one is bilateral system, where the variation is permitted in the two direction of the dimension. You can see here 25 plus or minus 0.4. So equal variation on either sides. Upper limit is 25.4 and lower limit is 25 minus 0.4. And here we have unequal tolerance, right, on either sides of the basic size, 25 plus 0.4 and 25 minus 0.2. So these are the references that I have referred. Thank you.